Next up, it's Martynas, Jusevičius, with linked data templates. It's an RDF semantic web presentation now. And I'm personally looking forward to this, so yes, please take it away.
Yes, so I want to talk about linked data templates, which is an ontology-driven approach to read-write linked data. But I'd like to start with talking a little about our software, which is built on this approach, and it's called Atom Graph, and then work back to the article. But I don't want to show too many slides. I'd rather go to the demo afterwards. So what is Atom Graph? I don't know if you tried some linked data browsers at some point. You might have heard about Graphity, which started as a linked data browser, and that was the name until recently, but we were required to change it legally because of trademark issues. So now it's called Atom Graph instead of Graphity. And what is it then? So it's a cloud-based linked data application platform delivered as a service in the cloud. And the interesting thing is here that the applications itself are in RDF. They are defined as RDF, so you could say it's a kind of RDF application container, in other words. So the environment is completely multi-tenant, as you would expect for a cloud platform, which means users have their own accounts, they can log in and have different access rights, and can collaborate on the applications. And one quite important thing is that no programming is required in the traditional sense. They don't have to write Java or PHP, they don't have to build web applications, because everything is just done through the user interface. So let's say they have an RDF dataset, they want to publish online, or they want to build an end user application for it. They can do all of it through our user interface, only using Sparkle to define the application structure. And if they don't like the default layout, then they can change it by uploading some custom XSLT as well. So because everything is, all the structure is in RDF, and users have to be able to define that. So we had to build, of course, a RDF data management system. So that is integral part of the platform. So as I mentioned, we have been developing it since 2011 under the name of Graphity, and it's only a month maybe since we changed the name. So some of the clients include NXP Semiconductors, and their project, I think it was called Enterprise Data Hub, won the first European Linked Data Award last year, I think, and we built the front-end application for it. Another client was State and University Library in Denmark. So this is a screenshot from the library application, and it represents quite a typical use case where the client has either data that is already in RDF, as it was the case with NXP, or it can be easily mapped to RDF, let's say from XML. Well, in this case, it was a little more complicated than that, because what we got was actually 3 books. So our partner company scanned the books and produced, we defined a TI schema, and then they produced the TI XML. And from that, we transformed directly into quads. I think it was the TRIX format using XSLT. That's how we got the RDF data. And on top of that, we used our application. So typical use cases are, for example, providing access, collection access over data, or container, in other words. So you can see links to those on top. Those are 4 main categories: places, newspapers, and so on. And here you see the newspapers. And this access is paginated, which means you can browse through the pages of the collection. Also, usually the clients need search, either structured or text, or both. And they need a custom interface and custom structure of the web page. So both things are on display here, Sparkle and XSLT, but this is behind the scenes. But what you can see on the left, for example, is the faceted search that filters. The user can combine the filters, and then the collection contents get filtered according to these criteria. So here, for example, only 2 newspaper types are selected, and all of them come from the Schleswig region, which used to be Denmark, now it's Germany, I think, or the other way. And yeah, also in the corner there's a text search, simple text search, and you can see the count of how many results match this particular criteria. And there are different layout modes in this application, like maps that display, have a geographical display of where the newspapers come from. So the data was about historical metadata about newspapers in Denmark. It came in three volumes of books. So who published the newspapers and when, and stuff like that, but not the actual newspaper content. So, and we used quite a few features for this website, but it was a couple of years ago, so we've progressed since then. And what we have now implemented is, as I mentioned, fully customizable structure and interface with Sparkle and XSLT, full grid-write data management, either through a linked data layer, that is to say over HTTP, or the user can achieve the same thing in the user interface. We have some basic data import support right now for CSV and XML, but we're planning connectors to relational databases. Then access control is enabled on a resource label, which means every user or a user group can have different access to a specific linked data resource or a class of resources. This is based on the W3C ontology. And then layout modes can be configured also, let's say table or grid or list for the same data. There can be multiple layout modes. And then we have some analytical interfaces, or working on it now, for example, plotting data on the map and then defining criteria, let's say calculating price per square meter for some apartments, and then changing the colors of the markers based on the prices, so the user can analyze those data objects on the map. Text and structure search, I mentioned that already, and the platform is compatible with any Sparkle 1.1 supporting backend, but we're using Dydra, which is a cloud triple store, and we have some custom optimizations in place specifically for Dydra. And I want to mention, to thank James from Dydra, because he provided quite a bit of feedback on my article. So now coming back to the article, this is the linked data templates architecture that our platform uses. So in the middle, it's the linked data application. On the left side, you see 2 different clients. And on the right side, you see the backend, or the data set backing the application. It's where the data resides. So the clients send linked data requests to the application, and they get back linked data responses with RDF. And then in turn, if they want to display a website for the users, in other words, HTML, then there's an extra step, which is a transformation of RDF XML to XHTML. And then they can read back the data from HTML forms using RDF post and send back to the application. Yes, and on the right, we use Sparkle as a protocol to connect to the database, because that makes the application independent from specific implementation details. It could be the data set could be stored in a relational database with some wrapper on top of it, or it could be stored in MarkLogic, for example, which is a mixed database. As long as there's a Sparkle interface, we can use it. But the central part is within the application. It's the ontology. So that is the application ontology, and one application has one ontology and uses one Sparkle service. And in the ontology, that's where linked data templates reside, and I'll get to the templates in the next slide. But in the real world scenario, probably this picture is a little more complicated because on the left side, there could be a proxy cache that caches the linked data request, and on the right side, there could be another cache that caches the RDF results from the triple star. Yes, and in some cases, for example, the client that, or that's how it is done in our platform, the client that does the transformation to the web page is actually part of this central application. So they're, like, the client and the server are baked together into one component. And so that's the basic architecture that we came up with. But then, because ontology is also RDF, so we thought we can move the ontology to an RDF data set as well, and then make some kind of meta application to edit the ontology. So in that way, we can generate higher level applications that still fit the same architecture, but they're on a higher level of abstraction. So that's what the end users work on, or administrative users. So now to the templates. So on an abstract level, a linked data template, I guess you could find many parallels with XSLT template just for linked data, or RDF instead of XML data model. So on the abstract level is like a function or mapping from the URI identifier space to the RDF representation space. And it is done by taking a request URI, let's say a linked data request URI, matching against templates in the ontology, and from that you get a query which then can be executed on the Sparkle service. So a linked data template has two components, main components. It can have many optional properties not shown here, but two main components are the linked data, the URI template, and then the query, or the query template. So the template is on the left and the query is here on the right. So what I highlighted in bold, the LDT path, that holds the linked data, the URI template for this linked data template. So that means this template will match when the request URI minus the base URI of the application, just the relative one, will match this URI template. And this is the JAX-RS syntax. JAX-RS is the Java RESTful API or something like that. So let's say the request URI matched this template. Then we go to the query value, the second property, which is the LDT query. And there we have some query defined, which is the query here on the right side. And the query is encoded using spin syntax, which is, I don't know, do you know spin, any of you? Spin RDF? Okay, a few people. And so spin is like reflection for Sparkle, you could say. It's Sparkle expressed in RDF syntax. So that's where it is. In the latest version, you can just put Sparkle string directly into this text property, but in principle, spin could generate a whole RDF structure of the query with all the variables that have basically an RDF representation of the query from which you can go back to the Sparkle query string again. So yes, and there is a special convention, a special variable similar to spin again, and it is this, also highlighted, which will stand for this request URI that matched this template. So before the query gets executed on the triple star or over Sparkle, this variable will be replaced with the actual request URI value. So this is, I tried to highlight the mapping from the URI, and the URI then becomes part of the query. Any questions so far? Okay. So this is the slide where I try to make some bold claims that we actually enable some new declarative software paradigm with linked data templates, because linked data, I think, linked data, it could be reconciled with the original semantic web vision, or let's say like this. For example, URIs are the uniform identifiers, and HTTP is the uniform protocol for data, right? And RDF is the uniform data model that can accommodate all kinds of data. But how these things work together, it wasn't really defined, at least on an abstract level. So we didn't come up with any new technology. We just combined existing technologies, including Sparkle with RDF, in a new, meaningful way, and provided an abstract model for it. Abstract model for read-write linked data. And W3C tried, or they have a specification for read-write linked data, and this is Linked Data Platform, or LDP, but I just don't think it is good enough. And I think actually this approach is superior, but I still need to convince a lot of people. So yes, because we have this abstract model, and read-write linked data is basically the web of data. So we have a uniform API for the web of data. You could put it like this. And if you go back to the original semantic web vision, or the article by Tim Berners-Lee in 2001, I think, in Scientific American, it is very much about ontology-driven applications, and then exchange of these ontologies by software agents over networks. So this is exactly what we've done here, because ontologies encode the application structure, so they can be composed, they can be reduced, they can be dereferenced, so they can be exchanged between the applications, and maybe forked, so to speak, or changed or adapted for a new use case. And the templates, they don't have to break existing ontologies, because we've used annotation templates, so you can annotate your existing ontologies with the properties and classes from our vocabulary, and just feed it into the processor, or do it through our user interface. And then hypermedia, I don't know how many of you know, this is like the last constraint of REST, but that most RESTful APIs, they don't ever implement, or implement wrongly. And there is also an effort that tries to do it right, called Hydra vocabulary. And I think they have the right goals, but still they do it in the wrong way, because they don't want to use the formal ontologies, because that's hard. They want to use the lightweight APIs and JSON LD and JSON. So yeah, but hypermedia means that in our platform, every resource or every page is an RDF resource with its own URI, but it is connected to the rest of the resources. So there is connection between all the states in the application. So, and the processor or the application generates all the possible or the meaningful states for client to follow from the current state. So it means the client can be very thin. So, and yeah, the last point is that the client and in general implementations can become generic, just like XSLT processors are generic, because we take out logic out of source code and put it into data, put it into ontologies, and yeah, that's how we do it. Okay, I'll try to do the demo now, see how that goes. I did a sample application using the XML London data, and created two containers. One is for the papers, and the other one is for people. And then you can click also on the people, but the containers are actually in the data set of our application, which has this base URI. But because the XML London data, it has a different base URI, which is data semantic web.org and so on. So we can't, if we go directly to that URI, so we leave the application, that's not what we want. So in this case, what happens that the linked data browser kicks in. And even though data has a different base URI, we still can display it in the same way because we use the same style sheet and so on. So how did I achieve that? Okay, let me try. So I have prepared a query which constructs the organizations. This is the Hydra interface, by the way. Construct the organizations from the default graph, and then adds some metadata that they belong to the container that I will create. Okay, so here, for example, if I go back to root, I can't create anything here because I'm not logged in. But if I am logged in, then I have more options, more controls. Yeah, you see my login on the right. So what I need first is a new collection or a new container. Oops. And let's store organizations in that one. Or not actually store, but they will be displayed under that container. So this is the human readable title, and this will be this relative URI part. Organization. How much time do I have?
About 3 minutes, but it's okay.
Okay. So I have the container, it's empty now, right? And then I take the query that I have prepared and go to this sitemap application, so to speak. And there are three, the main ones: access control, and apps, and then this sitemap. So first I need a query, which will be part of the template. Yep. So, what should I call it? I've done some previously, so I'll do that. And it has to be defined by the XML London ontology. This is the label. Okay, now I take the query. And you can see this has to be part of it, also here. So in this case, it will be the container URI. Looks good, I guess. Okay, so we have the query here. Now we need the actual template, and I've done some previously also. So I'll just see how it was. Okay. There's all the optional properties that I mentioned, which we don't need here. again, defined by XML London. And we want to order by some specific variable, which is name. And then I select the query I created previously. Select orgs. This is not important. Ouch. Deleted too much. Sorry. And yeah, okay, let me just fill out this once again. Almost there. So, okay, what I had here, XML London, construct orgs from default graph, GPL container, and now the URI template for which I need to use this part, the relative URI of the container that I created before. Okay. Okay. That looks good. Okay. Try here. Still nothing, I guess. Yes. Then I go, what I need to do, the last thing is to clear the ontology, so it reloads the templates again, and new templates go into effect. Oh, you didn't see that. Okay, let's try now. Boom, there it is. So you see the organizations from the data set. So that's pretty much it, what I had to present. And the next thing we want to do is to standardize this using the community group process from the W3C. And we have a community group for that, Declarative Linked Data Apps. And if you want to join that, you're more than welcome. If you want to try the software, then you can drop me an email or Twitter or tweet. So yeah, any questions?
Thank you, Martynas. Yes, any questions from the audience?
From where did you say was the data on the people?
It's all from the conference data set.
Probably not, because I looked up myself, and this is not the data coming from there. It's data coming from I don't know, W3C conference 2012, what is there for me, not from this conference.
Okay, but if you use those URIs, right? So if you click on that link, you'll go directly to the original link. Right?
Those URIs, yeah, they were designed to live elsewhere, but it was XML London that created those URIs. So those URIs, data.semanticweb, they truly are part of this conference. And all of that data lives here. So I guess you took this data from the RDF data from the XML London triple store.
Yeah.
And it all just works magically. You just get all the triples, just load them in.
I mean, how it works right now, that if the application sees, when it renders the interface, when it sees a URI that is external to the application, in other words, it's not relative to the base URI of the application, then it renders this, it puts the URI into parameter, which then triggers the linked data browser mode, because you're basically leaving the application, right? It's a tricky thing, for example, because the data you have about resources from the data semantic web namespace in your data set and the data that is actually on that, you know, when you look up that address, it could be conflicting in principle. So this is the nature of linked data. And yeah, we're only now starting to exploit that. Does it explain, or?
No, I don't know why there's not this relevant data there.
Because you just follow your nose principle, right? Just like browsing web pages, browsing linked data. Because the URI was data.semanticweb.org, when you click this URI, then we load the data from there. When you look in the container, then you see the data that comes from the XML on the data set. But when the URI is external, then the browser mode is triggered. And then with the reference and pick up the data. That's how linked data works, right?
Yeah. Are there any other questions? Okay. Thank you, Martynas.
Thank you.